Hello and welcome to this Dr. Ross video on multiplying algebraic fractions requiring prior factorisation, including a non-monic quadratic. And in case you don't know what non-monic quadratic means, it just means you have a quadratic where there's a number in front of the x squared that's not 1. So we've got 3x squared, so it's a non-monic quadratic. If it was just x squared plus 4x minus 4, it would be a monic quadratic. Mono means one, like monorail has one rail. Now we saw in a previous video that we just need to factorise everything we can, and that makes it easier when we multiply these together because we can cross cancel. And if you haven't seen that video yet, please watch that first. So what we're going to do is we're going to first factorise everything we can, and then we'll worry about what to do next. So x plus 2, there's nothing you can do with that. There's nothing you can factorise out of that. What about x cubed plus x squared? We'll always check what these might have in common as a common factor. X cubed and x squared have x squared in common, and then you put a single bracket, so it's a single bracket factorisation if there's something common you can factor out. Now x squared times what is x cubed, where it's x, and x squared times what is x squared, well it's just 1, so we put plus 1. That would expand out to give that. Now what do we need to times it by? Now again, we've got a common factor for the first and the second term, always check for that first. 15 and 10 both have 5 in common, and x squared and x both have x in common. Then we put a single bracket. 5x times what is 15x squared? Well, 5 times 3 gives you the 15, and x times x will give you the x squared, so it's 5x times 3x. And then 5x times what is minus 10x? Well, it's minus 2, because 5 times minus 2 is minus 10, and we've already got the x. What about the bottom? This is where the non-monic quadratic comes into it. Now I'm going to do it down here. And if you don't know how to factorise non-monic quadratics, please view my video on that first, but I am going to quickly recap it. So what you need to do is you need to find two numbers that add to give the middle number, the number in front of the x, which is 4, and times to give the first times the last number, which is why we sometimes call this the AC method, because that's A, B, C. We're looking for two numbers at times to give A times C. Now 3 times minus 4 is equal to minus 12. So we've got to think, what two numbers add to give 4 and times to give minus 12? Well, I believe it's 6 and minus 2. So what we do is we split the middle term, as we call it, into the plus 6 and the minus 2. And it's plus 6x and minus 2x, because if you think about it, 6x minus 2x would just simplify to 4x. We haven't changed that. We've just split the 4x into the 6x minus 2x instead. And then we just fill in the rest of what we got. The 3x squared is still there. The minus 4 is still there. So this hasn't changed. It's just that's been split up. And then what we do is we underline the first and the second half and see what we can factorise out of each. Now, what's common to 3x squared and 6x? Well, 3x's. So 3x we can take out, single bracket. 3x times what is 3x squared, well it's x. 3x times what is 6x, well it's plus 2. Then I always leave a gap and then repeat that bracket here. And then you think, what goes in the gap? What times x plus 2 is minus 2x minus 4? Well, it's minus 2. Minus 2 times x is minus 2x. Minus 2 times 2 is minus 4. That works. And then finally, can you see here and here we've got a common factor of x plus 2. So we factor out the x plus 2, have a second bracket, and then think x plus 2 times what is this? Well, it's just 3x. And x plus 2 times what is this? Well, it's that minus 2. The quick way is just this bracket here becomes one of the brackets, and anything outside the bracket, so the 3x minus 2 becomes the other bracket. So basically we've now got this denominator here, so it's x plus 2, 3x minus 2. And then we divide top and bottom, numerator and denominator, by anything we can. And it could be within the same fraction. So for example, within this fraction, top and bottom, we can divide by the 3x minus 2. But we can also diagonally cancel. So the top and bottom, but in different fractions, we can still divide by stuff. So I can divide this x plus 2 by x plus 2. And anything divided by self is 1. Like if I divide 10 by 10, you just get 1. And we can divide this to just leave 1. What else can we divide by? Well, we've got 5, but there's no 5 related stuff here. We've got an x here and we've got an x squared here. Well, they both have x in common, so we could divide by this x. There's no point in putting 1 because 5 times 1 is still 5. And we can divide by an x here to leave just x. X squared divided by x is just x. Now let's see what we got left. We want to multiply the numerators together. So we've got 1 here and we've just got the 5 here. That's all we've got. So we're just left with 5. And in the denominators, we've got x times x plus 1. And all we've got left here is just a 1, so we can ignore that. Anything times by 1 itself. So we just got x times by the x plus 1. And you could expand the denominator, but factorized or expanded form, neither is simpler than the other. So both of these are simplest forms. So we can just leave it like that, and that is the final answer.